Alright, hello. So this is part 2 of energy and changes in matter. I left off with the critical thinking questions. So number 7 asks to verify that it takes 4,140.7 joules of energy to heat 12.7 grams of water from room temperature to the boiling point. And it gives you specific heat of 4.18. So this is no phase change. So Q equals MC delta T. You're given your mass, your C, and your delta T is 100 minus 22, and you get 78. So you plug it all in, and you get 4,140.7 joules of energy. Number 8 says, given the fact that delta H of water is 2,260, we know that 2,260 joules of energy is required to vaporize 1 gram of water. So to vaporize 2 grams of water, it's 4,520. For 3 grams of water, it's 6,780. And it has to verify that it takes 28,702 joules of energy to vaporize 12.7 grams of water when the water is already at its boiling point. So this is a phase change. So you use Q equals M delta H. You're given your mass, your delta H, and you plug it in. You get 28,702, which is verifying it. Number 9 says, verify that it takes 1,513.6 joules of energy to heat 12.7 grams of steam from 100 to 159 degrees Celsius. The specific heat is 2.02. So this is not a phase change, so Q equals MC delta T. You're given your mass, your C value is given to you, and your delta T is 159 minus 100, so you get 59 degrees Celsius. You plug it all into your equation, you get 1,513.6 joules of energy, which is verifying it. So question 10 says, using only your answers to questions 7 to 9, calculate how many joules of energy it takes to change 12.7 grams of water at 22 degrees Celsius to steam at 159. So question 7 to 9 were all different steps for taking 12.7 grams of water from 22 to 159 degrees Celsius. So all you have to do is add these answers together, and you get 34,356.3 joules of energy. Question 11 says, calculate how many joules of energy would be required to change 32.9 grams of water at 35 degrees Celsius to steam at 120 degrees Celsius. It gives you the hint that you'll have to break it up into 4 steps. So part A says find the joules needed to heat the water to the boiling point. Q equals MC delta T, because this is no phase change. Given your mass, your C value, because it's water, is 4.18, and your delta T is 100 minus 35, and you get 65. Plug it into your equation, and you get 8,938.9 joules of energy. Part B says find the joules needed to vaporize the water. So this is a phase change, so you use Q equals M delta H. You're given your M, and you know your delta H because it's vaporization, which is 2,260. You plug that into your equation, and you get 74,354 joules of energy. Part C says to find the joules needed to heat the vapor from boiling point to 120 degrees Celsius. This is no phase change, so use Q equals MC delta T. You're given your mass. Your C value is 2.02 because it's steam. And your delta T is 120 minus 100, you get 20 degrees Celsius. Plug that into your equation, and you get 1,329.2 joules of energy. Part D says to answer, or to add all your answers, because they're each the different steps. So you add them, and you get 84,622 joules of energy. Question 12, asks how much heat energy would be required to change the temperature of 125 grams of ice from negative 32.9 degrees Celsius to liquid water at 75 degrees Celsius. So when it's in the state of ice, or solid, it's Q equals MC delta T, because there is no phase change. So you're given your mass, your C value is 2.06, because that's when it's ice. And your delta T is, since the final value would be 0, so it's 0 minus negative 32.9, which is minus negative, it's positive, so you get 32.9 degrees Celsius. You plug that into your equation, and you get 8,471.75 joules of energy. The next is fusion. So the next part is fusion, which is Q equals M delta H, and you're given your mass, you know your delta H, which is 334 for fusion, and you plug it into your equation, you get 41,750 joules of energy. And the last state is liquid. There's no phase change, so Q equals MC delta T. Your M, you're given your mass, you know your C value because it's water, so it's 4.18, and your delta T is 75 minus 0, so 75. Plug into your equation, you get 39,187.5 joules of energy, and you add them all together, and you get 89,406 joules of energy to change it from negative 32.9 degrees Celsius.